This is the work for section 4.2 problems, and I wanted to do this video to go step by step on what you need to do. So number one, we're pulling all together what we've been learning from chapter 3 and section 4.1. So you're given an initial tableau of a linear programming problem, and we're supposed to use the simplex method to solve it. So we've got this here. And to choose where to pivot from, you look at the bottom row and you pick the most negative indicator. See, below this line are the indicators, and the most negative is negative 50. So we know that's the column we need to look at. Then you find the quotients in the constraints. So you have 8 divided by 2, and you have 10 divided by 10. You want to pick the smallest constraint. That's the 10 over 10. So this number right here is our pivot. And what that tells you is that that row is, you're never going to change that row. You're going to work off of that pivot. And so we want to make this a 0 and we want to make this a 0. So when we're looking at row 1 and we want to pivot off of this one, what can we use to make 2 turn into negative 10? Because you got to add these and get a 0. So if I multiply negative 5 times row 1 and I add it to row 2, I can get a new row 1. You never get a new row 2. So here I've shown you that I multiplied negative 5 by everything in row 1. So everything in row 1 got multiplied by negative 5. Then I wrote row 2 down. I added them, and in yellow is my new row 1. And I suggest that you don't try to shortcut and not write everything, because then you could get lost way too easy. So then I rewrite the whole tableau using my new row 1. So I put this yellow thing right here. And then I write row 2 and row 3 just like they are. Now my goal is to make this negative 50 a 0 as well. And it's already negative and I've got a positive here. So if I multiply this by 5 times 10 is 50, I'm going to add those and get a 0. So 5 row 2, 5 of these, plus the row 3 gives me a new row 3. So I write that down. I write where I multiplied by 5. I added that row here. Then I put row 3 here. Now when I add, I get a new row 3. So this yellow is my new row 3. I once again write everything over. So here's my row 1 from here. Here's my row 2, which has not changed. And here's my new row 3. Well, once you get all zeros in your column, except where you were pivoting, you should be able to read a solution. And so if there's all zeros, then you're going to get a number. If there's all zeros and one other number. But here we've got 2 numbers, so that x1 is 0. Here we have a 10 and we have a 10 here, so 10x2 equals 10. That means x2 is 1. Here we don't have any zeros. x3 is going to be 0. Here we have 2 zeros and we have a number, so we're going to have an s1. Negative 5 s1 equals negative 30. Write that down, solve it, you get s1 is 6. And then you have 2 zeros and a 1 here, so 1z is 50, and you have solved what you needed to solve for this. It wanted to know the maximum, which is always the z value. It wanted to know the rest of these, and it wrote down what S1 and S2 were. So that is number 1. All right, number 2, they give us the initial tableau and say solve by the simplex method. Same idea. So here's my indicators, and the most negative one is negative 2. Negative 2. So I do the quotients of these parameters in that column. I've got 12 divided by 1, I've got 4 divided by 2, and 4 divided by 1. The smallest of those quotients is the 2, so that's where I'm going to pivot. We're never going to get a new row 2. We're going to turn this into a 0, this into a 0, and this into a 0. So we're doing the very same thing that we did in number 1. So on the first part, I know that if I could add negative 2 to this 2, it would become a 0. So if I multiply this row by negative 2 and add it to row 2, I can get a new row 1. So I've written that direction here. I've multiplied negative 2 by all the things in row 1. I write row 2 as it is, and then I add. And then my new row 1 is here in yellow. So every time I'm going to rewrite the tableau, just substituting the new row. All right, now I want to work on this row 3. And I've got a 1 here. If I multiply negative 2 times this row and add it here, I can make that go to 0. So same thing, multiplied negative 2 times that row, wrote down row 2, just like it is, added, this is my new row 3. So when I rewrite the tableau, got a row 1, a row 2, a row 3, I still need to fix row 4. It is a negative 2 there, so if I just add those two rows, I can get rid of that one. So row 2 plus row 4 gives me a new row 4. So I wrote row 2, I wrote row 4, I added them. This is my new row 4. Now I rewrite the tableau, putting in the new row 4, and I can do the solution. In this column, I have all zeros and one number, so 2x1 equals 4. In this column, I don't have anything. I don't have any, so x2 is 0. S1, and I think in this one we were only asked to find x1 and s2. They had all the others, but you could see that S1 was going to be 0. I mean, S2 was going to be 0. S1 was going to be 10 because negative 2 into negative 20. S3 was going to be 2, and Z was going to be 4. So same idea, same process. Now number 3, let's look at number 3, that we have to build this one. All right, so the directions say solve the linear programming problem using the simplex method. They've given it to us in constraints, not in a tableau, so we have to create the tableau. So here's our Z line, here's our constraints, and we have to find the solution. So I wrote the constraints here and put 5x plus 5x1 plus x2, and you have to add in your S1, your slack variable. You put that in, and all the way over here, you change it to equals 80. Then you have 9x1 plus 2x2. We have to put in another slack variable, move over, and then equals 100. x1 plus x2, we put in plus s3, and it equals 90. And this one just says x1 and x2 have to be positive. We don't have to do anything with that one. So if you have 3 constraints, you're going to have 3 slack variables. So now we should be able to write it. And I would suggest putting this up top just to keep you straight at the beginning. So 5x1 plus 1x2 plus 1s1, all zeros, and then 80. 9x1, 2x2, 0 there, a 1 there, 2 zeros, and a 100. Let me scoot down here. Then a 1x1, 1x2, 0, 0, a 1 in S3, 0 for Z, and 90. And now for the indicator line, you're going to move all of these on the right-hand side of the Z to the left. All right? So we have -2, -9, all zeros for the S's. You have 1 Z, and then we were left with 0 on the right. So that's how we come up with that line. Then we do the same thing that we did in the other problems. The most negative indicator is -9. In that column, and this is a split screen, I'm sorry about that, but in that column, the quotients are 80 over 1, 100 over 2, and 90 over 1. Well, the 100 over 2 is the smallest quotient. So here's our pivot in row 2. We will not change row 2. So we decide that if I can make that one there a -2, then I can get rid and make that a 0. Remember, your column where your pivot is needs to all be zeros except the 2. So -2, row 1, plus row 2 leaves a new row 1. I did the -2 times row 1, I wrote row 2, I added them, and I get a new row 1. Rewrite the whole tableau with your new row 1, row 2, row 3, row 4. Do the same thing to fix row 3. If we go back here, row 3 had a 1. So if I multiply -2 times row 3 and add row 2, I get a new row 3. So I did the -2 times row 3, and then I added row 2, and I get a new row 3. Now, we'll rewrite the whole tableau. And we have row 1, row 2, row 3. We need row 4. Well, there's no easy way to add 2 and -9 and get rid of the -9. But if you say 9/2 of row 2 plus row 4, you can get a new row 4. Because 9/2 times 9/2 times 2 over 1, that gives you a +9, and that'll make that go to 0. So this is multiplying that by row 2, putting row 4, adding these, and it doesn't matter that you get these fractions and crazy things, that's not going to be in your answer, but you got a 0 here. So this is your new row 4. So here's our whole tableau where we made that go to 0, that go to 0, and that go to 0. This x1 tells you x1 is going to be 0. Here we have all zeros except 2, so 2x2 equals 100. There's that. 2, let's see, what were we asked to find? Let's make sure. We needed x1, x2, and z. Okay, x1, x2, and x2 we got there, and then z, 1z was 450. And so those were our answers. So hopefully that helps you go through that completely step by step.